This morning, we focused on the working river. This afternoon, we're going to focus on the health needs of the river. We figured that if we know what the health challenges of the river are, then we can do a better job of beginning to figure out how to meld those values of working river with healthy river, like Justice Hobbs said, putting our values together, figuring out ways to create cross connections between our values. So in the Poudre Runs Through It Study Action Work Group, a big important part of what we wanted to learn about was, well, what in the heck does the river need that it's not getting? What are the health challenges? What does it mean to have a healthy river? Are there some indicators we should be watching? Well, a lot of different people are investigating, have investigated, and are investigating that question. So today we're going to have 5 experts give you their piece of the puzzle. We've asked each of them to give a brief slice of their perspective and experience pertaining to the river's health status, to let you look at their world through their eyes, look at the Poudre through their eyes. So we're going to hear a little bit about flows, we're going to hear about the riparian zone, and we're going to hear about fish. We're also going to hear about how all that fits together, and we're also going to hear about what's being done to tackle some of the challenges, such as water quality. So I'm going to let each of the presenters introduce themselves, and as we did this morning, we will be going at quite a clip. There's only a tip of the iceberg that you can accomplish in this bit of time, but we hope it really whets the appetite and helps you all become more interested in some of these challenges that we face. So with that, I'll turn it over to Sarah.
Thank you. Good afternoon. My name is Sarah Rathburn, and I'm an associate professor in the Department of Geosciences at CSU. And today, as indicated by my title, I'm going to be talking about flow. So that's the amount of water moving through a river at any given time, also known as discharge. And I'll be emphasizing the fact that flow is the dominant factor controlling the physical aspects of rivers. So it sets the physical template upon which then the rich biological and chemical components are built. But today is Saturday, and I've put aside my teaching hat, and I'm welcoming you into my home. And as you can see, I am influenced in my home decor by rivers. So as I was pulling this together, I also noticed there's lots of slides of rivers with my family members. So I think it also influences my parenting style. So whether or not you take on my home decor influences and my parenting style, what is sort of beside the point, but what I hope you do walk away with is some fluency with some 3 important concepts that I'll really focus on today: a process-form relationship, connectivity, and physical integrity. So the river process-river form relationship describes how water and sediment movement, the processes working on rivers, act to actually give it a form, to shape the river. It's a pretty simple equation to remember. I'm going to break apart and talk about water transport and sediment transport in subsequent slides. But you can see on the left there that these influence the shape of the river: the width, the depth, the slope, what we call the planned form, or how it moves in a horizontal dimension, and then a bed form in the vertical dimension. But water and sediment movement need to move downstream in an integrated, connected way. This is the connectivity piece, where the movement of mass, and there's a list of items that constitute mass there, and energy move between components in the river system. We can talk about 5 degrees of connectivity. The most obvious would be that upstream-downstream connection. From the uplands to the channel or the hillsides, what's moving down into the river. The floodplain channel connection. The groundwater channel connection. And then finally, the atmosphere. These 2 pieces, the process, river, and form relationship and connectivity, feed into physical integrity. And we say that a river has integrity intact if it's functioning as an active system to transport, store, and remobilize water, sediment, and nutrients. Physical integrity gives us one measure of river health. And here is my then 5-year-old son barefoot along the banks of the North Fort Cache La Poudre with snow still around and very cold water, but he's happy helping me evaluate the physical integrity of the river. So let's shape the Poudre River. The geology forms the substrate upon which then we act with climate, high, low temperatures, rain, snow, freeze-thaw cycles. And if we think about those factors subjecting on solid bedrock, that figure on the left is hard rock exposed in the bottom of the river, and what that might take versus shaping a river that's composed of unconsolidated sand and silt. It's a workout, if you will. So I'm going to emphasize a little bit of the workout that's provided by flow. It not only shapes, but it also supports and maintains. Sounds like a pretty good workout, one that if I knew that happened, I would certainly adopt that. Here's my daughter unwillingly help sample a bar on the upper part of the Poudre near Le Poudre Pass. This is a camping trip where she lost a tooth and it turned up in the butter. How many kids get to say that on a data collection trip? Moving to the larger boundaries of our watershed, the Poudre River with tributaries flowing downstream and ultimately joining the main stem, we can break out zones of the river from a mountainous region, starting at the headwaters in Rocky Mountain National Park on that upper slide, flowing down through the canyon, a transition reach through the city of LaPorte and Fort Collins, essentially to I-25, finally, through the communities of Timnath, Windsor, and Greeley, a plains reach. You can see that the river has very different form as we move downstream because of those vital components of water and sediment that are shaping it. There's also a geologic and a human influence here. So I don't want to ignore the human influence. We've heard a lot about that this morning. It starts in earnest in the mid-1800s with tie drives to support mining. We have irrigated agriculture and the digging of canals. That's continued in earnest with water supply projects, urbanization, road building, ag needs, and recreation and tourism. There's also another factor that shapes the Poudre River, and that's disturbances. And these actually disturb, reset, and change an ecosystem. Two that we're most familiar with, one being fire, and then subsequent post-fire floods and debris flows that move a lot of material downslope, and then floods. These disturbances really do shape the river, and often in a way in which it's a little more of a heavy lifting of that workout. So let's go to the river process side, the water movement. How much, how frequent, when is this required to shape the river? One way to describe river flow is a hydrograph, and you were introduced to that in the morning. And I'm going to go ahead and plot one that's similar to the 2002 runoff. That was a drought year. We describe the height of that hydrograph, the peak of it as the magnitude, and how long that lasts as the duration, along with frequency, timing, and other aspects about hydrographs. During 2002, we actually had flow that spanned the river, left a lot of vegetated bars exposed in the canyon and down through town. This could be thought of as the workout that would be the 2-pound dumbbells. Okay, there's low flow functions that you're going to hear about in another talk that are very important to riverine ecosystems. Let's contrast that with the hydrograph from 2011. It was 10 times the flow, much longer duration, filled the river bank full for a long time, so maintained that shape of width and depth. At some point, though, the 2011 snowmelt exceeded the height of the banks. There was a flood level, and water flowed out onto the floodplain and connected that flat area adjacent to the river as a functional landscape. Brought water, sediment, and nutrients out, end up fertilizing existing vegetation, and can rip up and remove old and weak vegetation and deposit new sediment to support the growth of new vegetation. This would be the 50-pound barbells that are part of the workout. So the flow variability ends up being very important to shaping, maintaining, and sustaining rivers. Let's go to the sediment side of that river process equation. Sediment moves along the bed. Usually at high flows, it tumbles and rolls. It's the coarser size fraction, the sand and coarser. It moves at high flows. And here's my husband, who is my best high flow sampler with his 6'4" frame. He is in the audience, so he was not swept away. And I don't think he's available for hire. The suspended sediment moves in the water column. That's the finer fraction of silt and clay. It often gives rivers the chocolate milk brown color. You can see it settles out and forms layers along the bank during receding flows. So that sediment has an important function. It scrubs the bed. It can remove fine sediment, algae, invasive weeds, and really enhances the habitat for fish and bugs. And I've mentioned how good the sediment can be for streamside vegetation and maintaining a rich riparian corridor. Some of the forms now that result. This is a paired image of 1937 and 2013, and you can see that from a plan form view, from a bird's eye view as we look down, the river has straight reaches, there's meandering, and then east of Greeley in that right image, you can see that it braids. So individual threads join beyond bars, similar to the braids of hair joining as in the braid. The plan form can change depending on how the supply of sediment and how the supply of water then change. So those vital components then influence the forms that we see. In the vertical dimension, the bed forms that we might see along the Poudre up in the headwaters would be a cascade. If there were water here, it would be tumbling over that deposit of boulders. A step pool where literal steps of boulders or logs end up forming discontinuities in the slope, and then pools scour on the downstream sides with another step as you move downstream. And then a pool riffle, and you might be more familiar with this because you see it in town, where pools form on the outside bends and riffles form on the straight crossings. So these are all the processes and forms that result. Before I conclude, I want to emphasize the physical integrity again, because there's a new piece to this definition, and that's the change, allowing change and movement of a river within limits set by society. So there is a human aspect of this, and physical integrity is not an all or nothing. In areas where the river needs to maintain more protection, that might get offset by areas where it is allowed to move and inundate the floodplain and create these functional environments adjacent to the river. But it all starts with flows. Flow variability is important from the yearly pulsings to sometimes the outbursts, the trickles, and the torrents. Those then help shape the river and maintain connection to the floodplains and other areas within the riverine corridor, and then support the physical integrity. But without flow variability and without physical integrity and connectivity, that's river illness. And I think we're all moving toward river health. So I'm encouraged by the number of people here. If there were only 20 discussing the idea of a working river, healthy river, that would be a problem. But the collective wisdom here is immense. And judicious use of that collective wisdom will really help us maintain the workout that the river needs for true fitness. Thank you.
Thank you, Sarah. My name is David Merritt, and I am a riparian ecologist with the National Stream and Aquatic Ecology Center in Fort Collins here, a national group that works on balancing human needs and ecosystem needs of rivers. We really do live in a spectacular geography by global terms. The fact that we live at the transition between the Southern Rocky Mountains and the Great Plains provides us with tremendous opportunities for wildlife and habitats that aren't represented anywhere else on Earth. The South Platte Basin is the basin that we're in, obviously, and it traverses this transition zone between these two ecosystems, the Southern Rockies and the Great Plains. And as a consequence, the ecotone that's formed by the overlap is very rich and very unique. This shows a picture of the Poudre River Basin inlaid within the South Platte, a small portion of the basin, but really traversing that gradient. And along this gradient, the forms of vegetation are tremendously varied, going from, as Alexander Humboldt explained, as you move down in elevation, it's similar to moving down in latitude. So at the very highest mountain peaks in Colorado, the stream channels and the processes and the vegetation is actually very similar to tundra and boreal forest. So we have riparian areas along streams and rivers and wetlands that are characterized by spruce, fir, alder, and birch riparian zones. And as you move down from these fairly rigid snowmelt areas that are basically resulting from snow fields and little alpine lakes into the canyons of the transition zone, you get a tremendous shift in vegetation from spruce and more of the montane vegetation to deciduous vegetation and more tree-like forms. And as you move out onto the prairie, the Poudre River and rivers like it along the Front Range really change into wide, less confined rivers that historically moved across the prairie and changed and shifted and formed extensive riparian forests. So the variety of vegetation is really a reflection of both the biogeography and the history, the geologic history of these sites and the species pool that was available and has remained here, and the geomorphic processes that Sarah Rathburn just talked about a moment ago. And so the forms of vegetation along rivers are so varied that rivers, and the Poudre in particular, occupies about maybe 1% of our landscape and represents about 80% of the wildlife habitat and diversity that we appreciate. So one of the sets of organisms that really relies upon riparian areas, in addition to humans for aesthetic values and whatnot, are birds. And our riparian forests along the Poudre River are so varied and so rich that birds migrate from places as far away as Costa Rica, talking about connectivity across landscapes. Across a continental scale, we have birds that spend part of the growing season nesting in the forests along the Poudre River. And they're doing that because the Poudre River is affording them tremendous structural diversity, tree and canopy layers along rivers, as well as water and insect diversity and fish and tremendous resources. So I would argue that one of the things that humans, as well as wildlife, appreciate the most about riparian areas is the fact that these are the elements of the landscape that provide shade and shelter and structure and nuts and berries and fruits and pollen and habitat for a wide variety of organisms. And it's a form of habitat that's not available elsewhere on the landscape. This is why I've spent my career studying riparian areas. So we have phrased these recently in the last 20 years or so as ecosystem services, but riparian areas really do provide a tremendous range of services both to wildlife as well as to humans. And this includes clean water. It's the main delivery mechanism for irrigation water, fisheries, food, recreation, aesthetics. I was surprised to hear about the number of visitors to the Poudre River every year. But that's supported, the draw is enhancing our quality of life by being able to go along a river and fish and sit in the shade and have a picnic lunch and recognize that these rivers are sustaining historic biological diversity, a natural heritage in the landscape that only these rivers support. So the things that make riparian areas and rivers can't be boiled down into two things, but these are the essential things. Biological connectivity is also an important factor, much as physical connectivity is, as Sarah mentioned. Biological connectivity along rivers, as I'll show you in a moment, is tremendous. It's like a venous network or an arterial network across landscapes. But the other thing that separates rivers from wetlands and prairie and upland mountain habitats is the hydrologic and hydraulic processes, fluvial processes that renew the landscape and renew the riverscape on a seasonal and an interannual and a decadal timescale, as we saw with the big flood this year. One of the interesting things about connectivity that intrigues me is that the way riparian plants move along rivers is similar to the way other animals and other organisms move along rivers. In fact, there's such a tremendous diversity of habitats or microhabitats or different climatic situations along the Poudre that we have completely different communities represented in different parts of the network. And if I can point here, you can see that different parts of the network of river channels could be north-facing or south-facing or up in a snowfield or down in a very hot prairie habitat. And plants actually recolonize after disturbances, the kinds of disturbances that Sarah mentioned, through basically dispersing their propagules along watercourses. And so if you look at the collection of different microhabitats along a river, plants really are able to recolonize these disturbed sites in part through adaptations to their seeds being released in synchrony with different components of a natural hydrograph. So plant seeds can remain buoyant for long periods of time, float downstream, and be deposited along a shoreline in response to their historic adaptations to the snowmelt hydrograph of the Poudre River Basin. And as this plot shows, this is a hydrograph, a typical hydrograph in the North Fork of the Cache la Poudre, and this is stream flow on the y-axis there, going up and down. And this shows the hydrograph, and it shows different families of plants that are adapted to colonizing riverbanks, and they are releasing their seeds at different times along the hydrograph, at different times along the receding limb of the hydrograph, placing their seeds in appropriate locations for them to reproduce or to become established and to form part of the plant communities there. Classic example is cottonwood trees, which release their seeds during the descending limb of the hydrograph. They need bare soils along river margins. They form little stands of little cottonwood seedlings that are, just tiny, and then form stands of vegetation that can form these extensive cottonwood groves that we've come to recognize and that are so biologically important. Now, this morning we heard a lot about water development and agriculture and some of the ways humans have affected the distribution of water across the landscape, and certainly agriculture and municipal water uses are key and very important. I contest that wildlife habitat is also something that is important to humans, and it's important for, as I mentioned, the natural heritage. I convened about 30 scientists, riparian specialists, and asked them to kind of list off what they thought were the biggest threats or stressors to these processes that I've described that support riparian communities. And water extraction and diversion and human use of water was the one that floated to the very top of the list among all of these others in this list. So as human populations along the Front Range continue to grow, and they're projected to be maybe double in the Poudre River Basin, almost 1 million people by 2070, the basin's already over-appropriated, water's already in short supply, and so the question is, how do we balance and retain some of these functioning ecosystems, riparian ecosystems, while at the same time providing for human water supply? So this is a picture of the current distribution of the dam infrastructure in the basin. And there are about 160 dams, I believe, in the basin, large dams bigger than 10 feet high. And these, as Justice Hobbs explained, they store water when it's abundant, and then they deliver it when it's less abundant. If you look at the number of diversions in the basin, we have almost 1,000 points of flow diversion throughout the basin. And this, again, is what enabled us to be able to settle and become so successful here, despite Stephen Long's prediction that this was going to be a barrier to westward migration of European settlement. Now, these diversions, actually, it's quite legal and quite common for these diversions at times to completely deplete a stream of its flows, obviously affecting aquatic and riparian systems in some pretty devastating ways. If you look at the Poudre River through Fort Collins, it's also been heavily confined to a very narrow channel, and we have developments going right up to the edges of the river's banks. Now this serves to really restrict and constrain the river from its natural processes of moving across a floodplain, a vast floodplain. And only on rare occasions, like the floods this year, does the river actually get to be laterally connected to riparian zones and to the riverscape. There are several endangered and threatened species that occur along the Poudre River corridor and its tributaries. Among these, Preble's meadow jumping mouse, leopard frog, and we actually have a species of orchid that is doing not as well as it used to historically, in part because of the way we're managing water. I find it interesting that as humans, we sometimes don't recognize the inherent value of this natural heritage of these creatures that are, they're as reliant upon the water as we are, and they have been around for as long as we have. And whereas we will protect historic human documents, the Hope Diamond, pieces of historic artwork behind locked museum doors with armed guards, often these creatures that are holding genetic heritage that is fascinating, amazing, valuable aren't as well protected. And with that, I thank you.
Good afternoon. My name is Boyd Wright, and I'm an aquatic biologist for the state of Colorado's Parks and Wildlife. Specifically, I'm in charge of conservation of native aquatic species in the South Platte Basin, including the Poudre River. I'm also a diehard fisherman, and I find it only appropriate to start off with a fishing story. I went to college at CSU, and I'd fished the Poudre River many times in the Poudre Canyon while I was at CSU. But it wasn't until I moved back to Fort Collins 3 years ago to transfer into my current position that I fished the Poudre River through the town of Fort Collins. And it was totally unexpected. It was a nice Saturday morning in July. It was cool, but one of those days you knew it was going to get sweltering hot. And I experienced a rare thing that fly fishermen dream about but seldom experience. As I was walking to the river, bugs of all varieties were emerging from the stream: mayflies, caddisflies, blue-winged olives. And the trout were dialed into this. They were feeding on these flies with reckless abandon, darting left, darting right, up, down, everywhere. And my friends and I proceeded to have a surreal fishing experience. Fish after fish after fish, browns, rainbows. Fast forward 2 weeks later, similar scenario, except this time I'm in a slightly different location, and instead of fishing for fun, I'm fishing for work. And I'm not having a very good day. It's hot out, I'm sweaty, I've got a hole in my waders, and I'm at this spot where the habitat is heavily degraded, and it's kind of bumming me out. On top of that, I've got buckets of thousands of fish that I've got to sort through and identify as species, and none of the fish are the ones I would hope to see in this location. In fact, they're mostly what we consider tolerant species that are reflective of this degraded habitat in that reach. But I tell these stories as a prelude to the 3 points I want to talk about today, and that is the uniqueness of a transition zone fishery, the multiple fishery values of the Poudre River, and in human-induced changes to the fish community in the Poudre River. And when I refer to a fishery in this talk, I'm referring to a group or population of fish living in a natural aquatic environment. Now, the transition zone is indeed a very unique environment. Why is it so unique? Well, it doesn't feature the cold water of the mountain streams, nor does it feature the warm water of the plain streams. Likewise, the predominant substrate is not the boulder and cobble of the mountain stream, nor is it the sand of the plain stream. It's somewhere intermediate. It includes fish that move downstream out of the mountains, such as trout, as well as warm water fish species from the plains that move up into the transition zone to take advantage of the habitat characteristics there. On top of that, it features a suite of fishes that are obligated to this narrow band of transition stream habitat along the Rocky Mountains. And there are multiple fishery values associated with this section of stream. We do population estimates of stream fish quite regularly as part of my job, and we've estimated recently anywhere between 1,000 to 1,800 trout per mile within the city of Fort Collins city limits. And these are both brown and rainbow trout. The brown are wild, and the rainbow trout we maintain through stocking, but both are introduced, but an important component to recreational trout fishing. And we've also done surveys to estimate the amount of angling within the city of Fort Collins, which to our surprise was greater to that in the Poudre Canyon. We've estimated 1,073 angler hours per month on average. That means for every hour spent angling by an individual added up, all totaled for the month. And there have been studies to determine the economic impact of angling. For a residential angler, that comes to about $67 a day of economic contribution. So the fishery value is important from an economic standpoint. But my specialty is in the area of native species conservation. And there are 32 native species in the South Platte Basin. And let me tell you, you may not be aware of many of them, but they are beautiful. There are 20 native species that were historically found in the Poudre River. There aren't near as many today. But why do these really matter? Why do these matter to you? Why do they matter to me? Well, they matter because they are indicators of river health. Certain species are reflective of the quality of the water and the quality of the habitat. Take, for example, the case of the common shiner. The common shiner was once widespread across all of our Front Range transition zone streams, but has been reduced in range to almost just one stream now in our state. It was once wildly abundant in the Quechua-Poudre River. This graph shows the proportion of sites that were sampled from 1970 to 2010 where the species was present. So going into the 70s, it was present at 60% of sample sites. By 1990, it had all but disappeared, and at present, we have accepted that this species no longer lives in the Poudre River. What do we know about the common shiner? Well, it likes clean, clear water, and it likes clean gravel in which to spawn. The case of the brassy minnow is similar in terms of its loss from the Poudre River, except it's a species that we generally regard as being very tolerant to environmental extremes. However, it's very picky about where it will spawn. It needs inundated floodplain habitat. It needs a river to overtop its banks slightly and to form backwaters in which this species can spawn. Now, important to maintaining these stream fishes, which actually are very tough, much like the settlers who settled this land, they got by on very little water and did so just fine. And oftentimes that was because of their ability to move up and downstream. So if in one area you had something occur that wiped out a species locally, it could be recolonized through upstream and downstream movement. But that's not the river system that we've created. Our system is fragmented longitudinally, such that fish can still move downstream, but they cannot move upstream. So it might be fine if you had one local issue, but as soon as you start to layer those on, chemical spills or sediment plumes, you start losing these segments of river one by one where the fish can inhabit, and they can't be recolonized from upstream movement. And that's what we've seen play out with these extinctions in a lot of our Front Range streams. I want to end by giving a quote. This was a quote that I heard when I was a student at CSU that had a profound impact on me. And it was from Aldo Leopold, who is regarded as one of the forefathers of conservation philosophy, also a diehard angler and hunter. But he said, one of the penalties of an ecological education is that one lives alone in a world of wounds. And sometimes that's how I feel, and I suppose that's how many people on our panel feel. But what our professor also told us is that we've got to find a way to live in a world with others with opportunity. And I think there are plenty of opportunities, and it's encouraging that there's such a large group here today. There's opportunities to reconnect the floodplain in certain areas. Obviously, this isn't going to work everywhere, but the city of Fort Collins, along with its partners, has already embarked on one project to do this. There's opportunities to restore longitudinal connectivity. There's a woman in this room that has spent the first half of her career studying how to get fish past barriers, such as diversion structures. There are opportunities to improve water quality, and many of these have already been pursued. And finally, we know that these fish need flows. We know the magnitude of flow they need and the timing, and there are certainly opportunities to improve that situation. Thank you.
Thank you, Boyd. My name is Joe Kunovic from the city of Greeley, and it is certainly a privilege to be here with so many people who have passion and spirit for this river and our water environment. I work out of the water and sewer department, out of the wastewater plant, and I have a lot of slides to go through, so I'm going to run through this pretty quick. But I will be talking today about nutrients in the river, in the ecosystem of our river, and some ways of possibly controlling that. This is a photograph of that one of my coworkers took of the river down towards the mouth of the river, or the confluence of the river with the South Platte. It's quite beautiful, quite nice down there. One thing I do have to say is that, you know, this river of ours, it provides life for us and for everything in this area. And all of us who take water out of it, put water back into it, and recreate in it, we're all related in one way or the other, because what happens one place has an effect on another place in this river. I happen to as well be a bird watcher. I took an ornithology class in college, and I was hooked since then. I took this photograph of a snowy egret. This is at our outfall into the river. And I picked this slide because I think it's a good indicator of the environment in the river right now. When you can have a wild animal like this hunting right in your effluent in the river, I think that shows a pretty good sign. This, on the other hand, is where we've come from. You know, we've all seen this story. We've all seen the pictures of the Cuyahoga River in Ohio, caught on fire, industrial pollutants everywhere, national uproar. EPA was eventually instituted, and under that EPA program, they came up with the Clean Water Act. And of course, the goal of the Clean Water Act is to restore our waters to swimmable and fishable conditions. I think we have done a great job. Industries cleaned up their wastewater discharges. Municipal plants are putting in more and more technology to clean up the water. But still, there are some challenges out there that we're facing to meet these goals. One of the major challenges we're facing right now is nutrients. We all know that nutrients are chemicals, elements that are essential for life and growth. And it so happens that the nutrients of phosphorus and nitrogen happen to be limiting. So in an aquatic ecosystem, when all the conditions are right, things become very opportunistic. And when you have lots of nutrients and excessive nutrients, you get a lot of growth. This is one of the effects of that growth. This is taken at a Stagecoach Reservoir near Steamboat Springs. And you can hardly see that disc that's maybe a couple feet deep. And you can see all that plant growth there. Some other effects from biological growth are algae blooms that can sometimes be toxic, depending on the algae. Eutrophication of streams and water bodies, which ultimately result in low oxygen conditions. And for a water provider that the city of Greeley is, we had some major problems at Boyd Lake, where we have a water plant, where a massive algae bloom of blue-green algae, in 2010, we were spending upwards of $4,000 a day to try and mitigate this foul taste and odor problem. Eutrophication, simply put, is an aquatic ecosystem in where nutrients are saturated in a dissolved state, and that in turn causes growth at a high rate. Sometimes it'll just go and go and go until there's nothing left, and you sometimes get dead zones. We've seen those big dead zones in the Gulf of Mexico. Some of the same things that happen from these are fish kills, taste and odor problems as well. This picture happens to be by Boulder Creek by Hygiene. I'm sorry. This is the photograph I took upstream of our discharge into the Poudre River. This is sago pondweed, and this was taken in 2007. If you look kind of across the middle section of the river there, that is actually where we do our flow measurements to calibrate our upstream gauge. That's the Clowasco flow gauge. And this again is an exhibit of the amount of growth that's just gone out of control. This really isn't a bad plant. It provides a substrate for insects, which again, ducks feed off of that, and apparently this is also a nutritious root system. But in our case, what we've seen is that this stuff hangs so closely to the surface and it slows down the velocity of the water to a point where it just becomes a sedimentation basin. And every year when we go out there during the summer, we go through probably 6 inches to a foot of sediment that has collected in this area. Fortunately, when high runoff comes in the spring, it scours a lot of that out. So what are the sources of some of these nutrient pollutions? In areas such as ours, we have so many mixed uses, but primarily they're point sources and non-point sources. Point sources, simply put, are pipes that put clean water back into the river. We're talking about wastewater plants, industrial wastewater plants, and confined animal feeding operations. The thing to remember about these is that the flows and quality are pretty much consistent all the time. There's some variability, but they're pretty consistent. One of the things that's a concern is if the upstream flows decrease, then these can become dominant. And if you look at this photograph, this is Metro Denver Wastewater's discharge into the South Platte River, which I would assume it's probably about 60 to 70% or more of the flow of the river. Examples of non-point sources are agricultural runoff, urban runoff, runoff from forests and grasslands. Eric from City of Greeley is going to be speaking later about what we've done to mitigate the runoff in the forest from the forest fires. Typically, these nutrients are carried into the water bodies through rainfall and snowmelt. However, we see a lot of sediment and other nutrients coming in from wasted irrigation flows, pretty much all during the summer. This is a bar chart that was developed from a CSU study in 2013 on nutrient load inputs into the river. This happens to be an urban setting at high flow. And as you can see, the contributions by non-point sources, agriculture and urban, far outweigh the contributions and loadings from POTWs. And the bottom there is the background amounts. So what's being done about this on a national scale and a regional scale? The state of there's nutrient regulations are occurring all over the country. In Colorado, nutrients are regulated in discharge permits at wastewater plants. We've had ammonia limits in our discharge permit for as long as I can remember. However, now the shift is going to be coming more towards total nitrogen and total phosphorus instead of just a portion of the nitrogen component. We also see that non-point sources are largely unregulated. Best management practices are encouraged. Recently, last year, 2012, some interim limits were adopted titled Regulation 85 by the Water Quality Control Division. And they're going to be implementing these new total nitrogen and total phosphorus limits in our discharge permits on the next permit cycle round. Our permits are good for 5 years. So we're expecting that in 2017, 2018, we're going to be either put under a compliance schedule or we're already in planning for this already, but we're going to be spending around $7 million to upgrade our facility to treat phosphorus. Boulder, I've been told, is around $13.5 million, and Fort Collins is probably in the $10 to $11 million range. And one thing is for certain that future water quality regulations are going to be even more stringent and more expensive, and we, as a service provider, pass that on to our customers. Some of the options that are out there and tossed around for dealing with these nutrient regulations are some nutrient trading alternatives. The concept here is where one regulated source will pay an unregulated source to reduce their nutrient load onto a river, and then in turn that reduces the nutrients discharged, and the regulated source will be able to claim that loading to use for their own sake. An example would be if a wastewater treatment plant pays a farmer to do precision agriculture. This would, the farmer would regulate how much fertilizer, how much nitrogen, phosphorus is going onto the property. They would also watch the wasting flows from irrigation, do some best management practices, and then in turn the state would then transfer that savings of nutrients back to the city. Then this could be used into their permit, so that we may not have to possibly spend another millions of dollars to meet lower limits. Some additional alternatives that have been discussed. Well, actually, the total maximum daily limit program right now, in effect, has been in effect for several years. Basically, if you don't know what a TMDL is, it's kind of like a pollution diet for a water body. This program is really shown to not be working lately. I just recently read a report from the government's Office of Accountability, in which they studied 35,000 of these TMDLs across the country. And unfortunately, these TMDLs are not really showing much improvement. They further looked at the point sources and did find that the point sources of 83% of those point sources are improving their discharges. On the other side of the coin, 20% of the non-point sources are only participating, and that's because this is a voluntary program. I come from a regulatory background in Clean Water Act, and if somebody has to volunteer to do something, they're most likely not going to do it. My point is here that I think the TMDL program needs to be restructured and rewritten, and everybody's going to have to be regulated with enforceability behind it. It's going to take a lot of cooperation, commitment, some socioeconomic balance, and lots of time. I don't see this happening for 20 years maybe until we're finally seeing some benefits from it. Another area that's being done actually in this state are scientifically based site-specific variances. For an example, right now we have temperature criteria limits in our discharge permit. Everybody across the state does in the Front Range, and nobody is meeting these limits. What we are doing is working with the state and collecting scientific data on the temperature in our mixing zone to show that, in fact, there are no problems in our mixing zone, although their effluent temperature is high. This is a variance that we can work out with the state, and it's a very good example of cooperation that's needed to meet some of these limits. Another concept are tiered discharge limits for wastewater plants. Right now, wastewater plants all the limits are based on a 10-year low flow number. And that's great. We need to protect the river on a low flow basis. But what we've seen is that a lot of times we never get to that point, especially in years where there's more moisture than others. Basing the limits on tiers that are based on the real-time upstream flow as well as the effluent flow opens a whole set of loading that can be worked with and still be protective of all the water quality criteria. In closing, I would like to say that I did have a chance to work under W.D. Farr, and that man had vision. He had great vision, and we are beneficiaries of what he did 40 and 50 years ago. And as an employee of Greeley and a citizen of Greeley, I feel it's my responsibility and our responsibility to do the same for our future generations. And I think these things can be solved, but it's going to take a lot of cooperation. Thank you.
Right, hi. My name is Jen Shanahan. I work for the City of Fort Collins Natural Areas Department. And I'm going to be closing out this hour with a talk about whole river health and looking at some themes that are consistent and important across the entire Poudre River landscape. And I just want to take a moment to say the 4 talks before me set a great stage for this discussion. This is somewhat of a recap, but they covered a lot of ground there and did an excellent job. But first, what is river health and why do we care about it? So up here on the screen is a definition I think we can all readily agree on. But beyond these intrinsic values, why else do we care about river health? Well, for one, the river serves as an index or gauge of watershed health, and the health and resilience of our watershed is an important factor influencing the resiliency of our communities to large disturbance events such as the recent fires and floods. Another reason we care about river health is because we are a headwaters region, and as a headwaters region, we have a great shot at clean water in a beautiful river. But I believe along with this comes a responsibility to manage it as best as we can. So my 3 themes for today are, no surprises here, connectivity, flows, and novel ecosystems. And you can think of this last theme with the words modern landscapes or modern working landscapes. And I'll come back to that in a few minutes. So first, connectivity. We've already heard about the types of connectivity and the importance of it in a river system. Here I am showing you the South Platte Basin, as Dave Merritt showed earlier, with all the diversions, and the Poudre Basin is up in the top left corner. I'm going to zoom in to the transition reach. So here we see the diversions just from Bellevue through Fort Collins. And this is just a demonstration of how fragmented the aquatic piece is in this system. The rest of the system is equally fragmented, from the river to the floodplain, etc. But the good news is that we're learning how to restore connectivity. Up on the screen are 3 projects where we are restoring or reconnecting the river system. You've seen this earlier today. This is from the northeastern neighborhood of Fort Collins by Shield Street. On the top, we've knocked down steep banks to reconnect the river to its floodplain along a half-mile reach of river. In the middle, we've taken out a relict diversion, and I'll come back to that in the next slide. And at the bottom, we're recreating an old creek that had essentially disappeared with land use practices. So the plan for this coming year is this schematic you see to reconnect Soldier Creek to the main stem. So as we saw this morning, the Josh Ames was an excellent model for a collaboration on a both community and regional scale. This project, which has drastically changed the landscape and improved the functioning of the river at the local level, was also supported by the Colorado Water Trust, the South Platte Basin Roundtable, and the Colorado Water Conservation Board. I think this project was an excellent model for how to fund complex, large projects. To my second theme, flows. We know that flows are the master variable of all river systems, but what I'd like to focus on today is how we can use our knowledge of the river to better manage the water we have for the mutual benefit of society and the river environment. In other words, how can we use the water for other uses and still meet the needs of the river? So it's necessary to ask the question, what does the river need? What are the most critical or key functions of flows? And the very simplified answer is that there are 4 key functions. The river needs high flows to refresh or reset the riverbed and to support riparian vegetation. And we need enough water in the river during the low flow months to provide adequate dilution and to maintain quality habitat. This approach of looking at the functions of flows that have a positive impact on the system is called environmental flows. You may think of environmental flows also with the term ecological demand in a similar context that we talk about agricultural demand or municipal demand. Environmental flows are being explored and applied around the globe. According to the International Union for the Conservation of Nature, or the IUCN, environmental flows are a vital tool for managing water in the municipal agriculture river nexus. So to identify values for environmental flows, we have to look to the past and the recent past to understand the relationship between flow patterns and ecological conditions. Then we need to zoom in on a specific reach and study the physical conditions to be able to identify values or thresholds for each of those 4 environmental flows. So based on what we know about the river today, how is the river doing? Well, we have some concerns. We have concerns about today's flows and future flows. Without careful attention to ensuring adequate water in the river or adequate flows, fish populations are likely to decline and become more vulnerable. We are likely to see further reductions in the abundance and diversity of aquatic insects and a shift in the base of the food web to more worm-like insects. The corridor of riparian vegetation is likely to narrow. And with reduced capacity for dilution, we can expect to see higher concentrations of nutrient levels. But despite this, I'm encouraged about flows for 2 reasons. One, because folks are talking. Like today, many productive, collaborative discussions are occurring in the Poudre Basin. People are coming from across disciplines, across the stakeholder groups to have reasonable and productive conversations. The other reason I'm encouraged is because of numerous data-driven studies that are now emerging to help fill in the numbers that help answer the questions from the water resources and management side, as well as from the environmental flow side. Only with numbers can we begin to solve this complex collective challenge. So to my 3rd and final theme, novel ecosystems. Natural resource managers are recognizing significant and fundamental shifts in ecosystems around the world as a result of human activity and human influence. So let's look at the Poudre. How is the Poudre River changing? Well, looking at the upper Poudre, at first glance, you may think that the river is not greatly affected by modern activity. However, we can consider the floods and fires of recent years. We do know that extreme events are a natural part of ecosystems. However, with a changing or shifting climate, these extreme events may be amplified, and we need to learn how to manage or work within this context. In the transition zone, the Poudre River has been greatly affected. I think of the analogy of a person with a complex medical problem who's taking a lot of medications. Each medication has a positive effect on one part of the system, but it may have an adverse effect on another part of the system. Similarly, the Poudre in the transition zone is being affected every few hundred feet by something, somehow. One topic we've been focusing on is the riparian corridor and how it is changing. As you heard earlier, the riparian corridor used to move across this landscape, and Plains cottonwood, the keystone species in the riparian corridor, depends on this shifting of the river across the landscape to be able to reproduce naturally. But as you see in the urban core of Fort Collins, the river cannot always move around on the landscape anymore. So we've looked into the forest to see what's coming up next. And we see a variety of non-natives that are not so desirable. We also see green ash is thriving in the understory of the Poudre River riparian corridor. Green ash is a regionally native species, and we find this to be a positive alternative to Plains cottonwood. However, with the arrival of the emerald ash borer, we now are anticipating that the green ash will be wiped out in the near term. So my point here is not to paint a dismal future about the riparian forest. Rather, it is to emphasize that there's a lot of uncertainty in novel ecosystems, in modern working landscapes. And associated with this comes a greater need to study and understand what is going on if we want to nudge the river in a positive direction. So I would be remiss to give this talk without mentioning that there are positive aspects to novel ecosystems. You know, the Poudre River has a legacy of gravel mining, and this has left a mosaic of aquatic and wetland habitats throughout the floodplain. This has created a tremendous opportunity for families with young children to go out and explore nature locally and safe. The other way, the other asset to the novel ecosystem is the potential for infrastructure. You are probably also aware that we are getting very close to completing a paved recreational trail all the way from Bellevue to Greeley, essentially from the canyon mouth to the confluence of the Platte. And that's just totally awesome. So with that, I'll be closing my talk, but I did want to share with you that I gave this talk to my father recently. And he said, "Well, that's great, Jen, but you're missing the whole point. A healthy river is a fun river." And he reminded me, in his Irish way, that for him, a fun river is flying into the cold New England waters head first. 30 years ago, 40 years ago. So with that, I'll close and ask that you remember at the end of today, when you leave, that to manage for a healthy and fun Poudre River, we need to reconnect the system, work towards environmental flows, and work to understand the complexities of the novel modern ecosystems. Thank you, and have a nice afternoon.
Thank you, Jen. I really like what Jen had to say at the end about the challenges, yes, are there, but we have plenty of opportunities. And one of the things that we have found, if not one of the most important things that we have found in our Poudre Runs Through It group, is that we're beginning to form relationships where those who are talking about these ecological issues are breaking through some of the barriers that some of those who've always talked about water rights have had, and those who on the other side have had barriers about water rights and what some of the diversions have caused in terms of causing problems for the habitat and the flows of the river, have begun to understand the other side. And so what we're finding is that indeed we can come together and look at this as a problem and an opportunity that we can all work on together. That if we take the point of view that either we have to go find a healthy river no matter what that does to the rights of those who own the water, we're not going to get very far. And on the other hand, if those who own the rights to the water say, well, we don't really care about those little minnows, we're not going to get very far. And what we've discovered is, again, what Greg Hobbs called the cross connections, where we figure out how to take all of our values and realize some of them mesh more easily than others, but we're all about trying to figure out how to build on what we can in common.